Hey, I hope you are here from the shorts. Now let's try to focus at the concept. The concept is known as inclusion, exclusion, principle. Now what does it mean? We are going to include some cases and we are going to exclude some cases. Let's cover the theory first, then we'll focus at some numericals. We have to count the number of ways. सबसे पहले हम ले लेते हैं total number of ways. अब हमें कुछ restriction given होगी, so we are going to remove that. Number of cases when restriction fails, when restriction or the condition fails at least once. कम से कम एक बार अगर वो फेल हो रही है उन्हें माइनस करा. अब इसके बाद हमें ऐड करना पड़ेगा नंबर ऑफ केसेस वेयर रिस्ट्रिक्शन फेल्स at least twice. And on a similar note, now we are going to subtract number of ways when restriction fails at least 3 times, and this process will be repeated n number of times. So this is going to be the general formula. Now let's solve a few questions regarding the same. Let's solve a question, and the question is, we have n different colored objects and n different colored boxes. Now put objects into boxes, one in each, such that no two color matches. तो जैसे कि हमने formula लिखा था, according to that we are going to solve this question. If we have n different colored objects and n different colored boxes. Okay, here we go. So now the number of ways can be written as, the term over here were total number of cases. If I have n different objects and n different colored boxes, then the total number will become n factorial. Now I have to subtract what? When the restriction is failing at least once. So I am going to choose one object out of n. I am left with n minus 1 objects and n minus 1 boxes. So the ways to arrange them will become n minus 1 factorial. Now I have to consider the case when the restriction is going to fail twice, at least 2 times. So nc2, and now I have n minus 2 objects and n minus 2 boxes. So it will become factorial of n minus 2 and so on. If I simplify them, then it can be written as n factorial minus nc1 is n into n minus 1 factorial. We have to add nc2. nc2 will be n into n minus 1 divided by 2 factorial into n minus 2 factorial and so on. This entire expression can be summarized as n factorial, n into n minus 1 factorial can be written as n factorial divided by 1 factorial. Then this number can be written as n factorial divided by 2 factorial. On a similar note, the next term will be written as n factorial divided by 3 factorial and so on. So if we see, the term is coming n factorial minus n factorial by 1 factorial plus n factorial by 2 factorial minus n factorial by 3 factorial. So we can write it as, the answer will be n factorial taken common 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial and so on till minus 1 to the power of n 1 upon n factorial. This is the final answer to this question. Thank you. Now let's solve the next question, which is exactly 2 objects are placed correctly. So now we are going to write nc2. I am choosing the 2 objects which are going to be placed correctly. Now I am going to multiply this with the remaining, which are n minus 2. So the formula will become n minus 2 factorial. In brackets I will write 1 minus 1 divided by 1 factorial plus 1 divided by 2 factorial minus 1 divided by 3 factorial, and this will go until minus 1 to the power n minus 2 1 upon n minus 2 factorial, and this will be the answer. As you can see, n is replaced by n minus 2 because two objects are placed correctly. So we are removing those two objects which are placed correctly and then applying the formula to the remaining elements, that is the remaining objects. Let's look at the next part, which is exactly 5 objects are wrongly placed. If 5 out of n objects are wrongly placed, this means n minus 5 are correctly placed. So out of n, I am going to choose n minus 5 which are correctly placed. Now I have to focus at the other 5. So it will become 5 factorial, 1 minus 1 upon 1 factorial, plus 1 upon 2 factorial, minus 1 upon 3 factorial, plus 1 upon 4 factorial, minus 1 upon 5 factorial. This will be the answer. And as you can see, we have replaced n with 5 because in the first case we were arranging n objects, whereas in this case we only have 5 objects which are wrongly placed and the other n minus 5 are placed correctly. Now the last and the best part is exactly one object goes to the wrong box. If exactly one object goes to the wrong box, it means that out of n, n minus 1 are going into the correct boxes. Now if I apply the formula, it will be 1 factorial into 1 minus 1 upon 1 factorial, and that's it. This is 1, this is 1. So this will become 0 and our answer will be 0. Now the answer is 0 because it is impossible for exactly one object to go into the wrong box. Because if one object goes into the wrong box, then there will also be, if object 1 was intended to go in box 1 and object 2 was intended to go in box 2, but if exactly one object goes in the wrong box, then the object जो B2 में जाना चाहिए था, it will also go in the wrong box. So it is impossible for exactly one object to go in the wrong box. इस वजह से the number of cases would be 0 and that will be the answer to this question. Thank you.